We will start sharp at 8 o'clock. Okay. Okay, morning. Morning, Hanta. Morning, Izati.
Good morning,
Anas.
sir.
Morning.
Morning, sir.
Morning. Okay, so I have 13 of y'all on Zoom and 24 of y'all on YouTube. Okay, I really hope to get nearly all 90% of the lecture here, right? 90% attendance line. If not, it's no use for me to conduct lecture. Okay, I give them 5 more minutes. Okay, so if you can, please wake up your friend lah. If I stop conducting lecture, it's your friend's fault lah, not my fault. Okay, please wake up your friend. Ask them to join as soon as possible. Okay, I hope that all of y'all can wake up your friend and ask your friends to join lecture as soon as possible. Okay, morning Izul, morning Nurul, morning all at Zoom. So, yep. Still waiting for your friends to join the lecture. Okay, sharp 2 minutes, I will start. Okay, sharp 2 minutes, I will start. So, yeah. Hope everybody is ready. Morning, Putri. Okay, I think everybody can see the screen already right now. Those in Zoom and those in YouTube, I'm sharing the screen right now so that you all can see the screen and we can begin lecture lah. Okay, morning Ain. So all can see the screen, right? Morning Ki. Okay, good then. So since everybody can see the screen and we can begin lah. Okay. Now that day we already learned how to find out how to start. Okay, how to find domain and codomain or range using what is this called? Graphical method. So today we are going to go on some more for domain and range in algebraic method, and then we will carry on some more. Okay, morning everyone, and let's begin the lecture for today lah. So I have around 45 of y'all in YouTube and only 20 of y'all in Zoom. So there's only 65 of y'all who joined the class today. Quite disappointing, huh? Okay, normally I will get around 100 plus, but yeah, today is only 60 of y'all. Maybe it's a Monday morning, so maybe that's the reason. Really hope that y'all can advise your friends to join the class on time lah. Okay. Okay, ready? Let's start line A there. What we are going to do today is how to find domain and range using algebraic method. Okay, we are trying to use algebraic method. So let's see the first question there. We have fx, okay, equals to x over x minus 3. So I know you know one thing, that x cannot equals to 3. And you also know y cannot equals to 1. This one I teach that day how to find. Yes or not? This is 1, here also 1. So 1 over 1. So y cannot equals to 1 there. Okay, and x cannot equals to 3 because of the denominator lah. Okay, so from here I can write down the domain of this function. Okay, domain of this function can be written as, you can write in interval form, no problem, negative infinity till 3 cannot equals to 3. Okay, union with 3 less than x less than or equals to infinity, or you can say all real numbers. Okay, you can even say that this is all real numbers. Okay, x is the element of real except 3. Understand? Except 3, but just make sure you write down all this in set form lah. Okay, you write all this in set form. Same goes with range of f there. The range of f, okay, that is going to be negative infinity till 1. Okay, union with 1 till infinity. So you can write down like this lah. Make sure this is in set form, that's all. Okay, now if you look at b over here, we know as a square root function, we know that inside the square root must be greater than 0. Okay, greater or equals to 0 lah, must be greater or equals to 0. So 3x minus 4 is greater or equals to 0. X is greater or equals to 4 over 3 there. So since x is greater or equals to 4 over 3, you know that the domain have to be, the domain of this function is just x greater or equals to 4 over 3 lah. Understand? Greater or equals to 4 over 3. But the range of this function over here, if I just take the positive value of the square root, so will be 0 to infinity. Okay, it definitely can be 0 lah. Definitely it can be 0. So 0 to infinity. You can even write down in interval form, no problem. Okay, you can write down like this, no problem. Okay, you can even say fx is just greater than 0, no problem. Okay, this is for fx. So fx is greater or equals to 0. You can say like this in set form, also no problem. So there are many ways to write your answer lah. Not only one way. Because some of you all message me and ask me, sir, can write like this or not? I say can, no problem. Okay. Same again, this is also a quadratic square root function. So x 1 minus x must be greater or equals to 0. So you know that from here that if you let x will become equals to 0 or x will equals to 1. So if you draw your curve, 0, 1. So it's here and here. Yes, not. So you know that x is less than 0, less or equals to 0. X is greater or equals to 1. So this is going to be your union of sets. Understand your definition of sets over here. So I hope this is clear for everybody. Okay. Then that is your domain already over there. Okay, that is your domain. Okay. Oh, sorry. My mistake over here. Sorry, my mistake over here because I did not expand the square root. I did not expand this quadratic function. This becomes negative x squared. So x squared minus x is less or equals to 0. So x minus 1 less or equals to 0. X equals to 0, x equals to 1. We draw here 0 and 1. So from here we know x is between 0 and 1. Okay, x is defined between 0 and 1. Okay, that is the domain there. Okay, once you get the domain ready, then to find the range, okay, to find the range, very simple. Square root we bring over, so it becomes y squared equals to x minus x squared. Okay, now if you look over here, I can actually shift and get x squared minus x. Okay, x squared minus x plus y squared. Okay, equals to 0 over here. Now, once I get this ready, we can complete the square a little bit over here. So I can get here x minus 1 over 2 square minus 1 over 4 plus y square equals to 0. So I know that x minus half square, okay, equals to 1 over 4 plus 1 over 4 minus y square. Okay, 1 over 4 minus y square. So if you really look over here, this is going to be the function lah. This is going to be your y value. This is going to be your y value. So here you can see that uh, 1 over 4 minus y square must be greater or equals to 0. If not, you cannot take the square root. If not, you cannot take the square root. So here you will tell me 1 over 4, or you can tell me y square minus 1 over 4 less or equals to 0. Here is y minus 1 over 2, y plus 1 over 2 less or equals to 0. Draw back your graph here. Okay, here will become negative 1 over 2, here will become 1 over 2. So since less than 0 will be here. Okay, and since we are going to take only positive value of y, so it have to be between 0 and 1 over 2. So that's why the range of this function is going to be between 0 and 1 over 2 over there. Understand? Despite taking negative 1 over 2 less than y less or equals to 1 over 2, but if I take negative 1 over 2, this is not a function. Why? Because it's quadratic. Any quadratic curve or any square root curve, okay, if I take the positive and negative part, if I draw a line, then it cuts at two places. When it cuts at two places, this is not a function. Okay, this is not a function. So that's why we cannot cut at two places over there. Understand? We cannot cut at two places over there. So I hope that is clear. Okay, that is clear for everybody. Okay, so we only can take either positive only or either negative only. Depends on the question lah. Okay, depends on the question. But normally we take, if the question never say anything, we take positive only. Understand? If the question never say anything, we just take positive only. Okay. Okay. The balance there, D there is nearly the same, so I won't do. Okay, I just want to see here. We look at number 1A here first. Okay, 1A here, very obvious, x plus 3, x plus minus 1. So I know that x cannot equals to 1 and y also cannot equals to 1. So the range, okay, the range of domain of the function is x is element of real except 1. Okay, except 1. And the range of the function also is x is fx is an element of the real except 1. Except 1. Okay, so that's how basically you see that. Okay, I hope until here everybody okay. No problem, right? Until here can. Okay, now of course you can see the next one there, C here. Okay, if I give you one C line, we take the next one here, we take D here. Okay, I do D. y equals to square root of 4 minus x squared. So 4 minus x squared must be greater than 0, greater or equals to. So x squared minus 4 is less or equals to 0. If you draw your curve, you know it's negative 2 and 2, so it's between here. So you know the domain of this function is going to be between negative 2 and 2 lah. Okay, and the range over there is very obvious. Okay, you can take y squared equals to 4 minus x squared. So x squared minus 4 plus y squared equals to 0. Okay, here will become x minus 0 squared minus 4 plus y squared equals to 0. Complete the square. Negative 4 plus y squared, you can shift the other side. So when you shift that, you get x minus 0 squared equals to y squared plus 4. Negative y squared plus 4. So negative y squared plus 4 must be greater or equals to 0. So y squared minus 4 greater or equals to, less or equals to 0. Okay, y minus 2, y plus 2 less or equals to 0. So from here you can tell me y is between negative 2 and 2. Okay, y is between negative 2 and 2 with the equal sign there. Okay, of course, you know that the function only valid if, let's say, is from 0 to 2 lah. Okay, 0 to 2. Why? Because y must be greater or equals to 0. Therefore, y is between 0 to 2. Understand this or not? Because we know that negative y square minus 4 must be greater than 0 there. Understand? That's fine. Okay, so y must be greater than 0 lah. Okay. So that's what we are saying over here. I hope until here everybody okay. Okay, I hope until here everybody okay. Any problem until here so far? Can understand this, everybody? Everybody can understand this so far? Yeah, I'm waiting for a response. If everybody can understand, then please let me know. Okay, then I move on. If got any question, please ask. Can everybody? Yes, huh? Okay, good then. So I hope now you all can start doing your what is this called? The function graph which I gave you all lah. Okay, I gave you all the function graph. I hope you all can start doing lah. Okay. Okay, so we move on some more. Okay, I will not do all the balance there. You can try and look lah. Okay, I explain to you all a little bit of demand, right? Not okay. So the next one here is called composite function. Under composite function, this means two functions we combine together. I think this one you all learned before in form 4, so no problem lah. Okay, never mind. Anyway, I explained this is the function from g to x. This is the function from f to g to f. G to f gx. Then function f lah. Okay, so if I want to tell you this is the function of x, this is the function of gx, and of course this is the function of f gx here. Understand? So the function of f is not given here. Okay, the function of f is not given. If let's say if I give you here x plus 1, so x plus 1 is gx. Okay, gx is x plus 1. Okay, and if I give you here 2x minus 1, therefore f gx is 2x minus 1. Look over here. See the difference over there. Okay, and you also must note that fgx is not the same as fx times with gx. Fgx with the dot there. Okay, okay. Nowadays they write like this. Sometimes they write like this. This is not times. This means fgx. That's all. Understand? This means fgx. That's all. Clear? Don't say, sir, this one means times, is it? No, this is not times. This is just fgx over there. So I hope that is clear for everybody lah. Okay, I hope that is clear for everybody. Okay, and of course, if let's say here is f, here is g, then of course the function from here to here will be gfx. Why? Because we write g first and then followed by f lah. Okay, actually we read this way because this will be the first function, this will be the second function. So I hope that is clear. If I put a k here, okay, kx, okay, here is d. So here will become what right now? Here will become kgfx. Okay, the k will be at the back. Understand? The first function was f, then apply g, then only apply k. So I hope that is clear lah. Okay. Now let's see a basic question over here, fgx. Let's find out how to get fgx here. So f there, okay, fgx there is 2 minus x. So now we get here 3, 2 minus x plus 1. So 6 minus 3x plus 1. So I get 7 minus 3x there. Okay, I hope that is clear. Now if I give g fx here, g fx is what right now? Oh, fx is 3x plus 1. So g there is 2 minus 3x plus 1. So here you get 2 minus 3x minus 1, which is basically 1 minus 3x. This one should be a very, very easy thing for you all, because all of you all have done this in Form 4 and Form 5. Yes, not 2 years you study this already. Okay, so should not be a problem lah. I hope everybody okay. Okay, just to do another one more here, maybe you can ask f square x. F square x here is going to be fx. So f 3x plus 1. Now put back again 3x plus 1 there. Okay, hold on. So you put back again 3x plus 1 plus 1 there. Yes or not? Okay, so from there you can get the answer straight away. So this one you learn in Form 4 at Maths already. Okay, so please don't come and tell me, sir, I don't know this one. Not right, right? So here you get 9x plus 3 plus 1, which is just 9x plus 4. Okay, done with that. Now here we go on. They have this fg and gfx here. They also have ffx here lah. So I do ffx lah. Okay, I do ffx again. Okay, so if you look at this function here, they give me f bracket 3x squared plus 1. Now you take this whole thing here and substitute inside this x over here. So you're going to get 3 bracket 3x squared plus 1 square plus 1. So here you're going to get 3. Here is going to be 9x squared. Oh, sorry, 9x power 4. My mistake. Plus 1 plus with 6x squared plus 1. So you get 27x power 4 plus 3 plus 18x squared plus 1. So 27x power 4 plus 18x squared plus 4. Done. That is your answer over there. Can see that, everybody? I hope until here everybody clear. No problem, right? All can do until here so far?
Yes, sir.
Okay, very good. If no problem, then good. Okay, so if we ggx there is quite easy lah. Okay, now let's see the next one here. Now we have gf3 here. So if gf3, so we put gf3. F3 means put 3 inside here. So here also you put 3. So you get 2 times 3 minus 1. So you get 6 minus 1 is 5. So g5 over here. Now take the 5 and put inside the g there. So you get 5 cubed, which is going to be basically 125 straight away lah. Okay, of course you can go and find gf. So first gfx. Okay, if you find gfx over here, you can see that gfx is going to be 2x minus 1 power of 3. Then you can put 3 inside. So 2, 3 minus 1, the whole thing power of 3. Okay, so here you get 125 straight away. So I hope until here everybody okay lah. Okay, I hope until here everybody okay. Understand until that so far? Can? Okay, good then. So to substitute should not be a problem lah. Everybody should be able to do. This is what you all have learned before in Form 4. Okay, yes, in Form 4, Rafiq. Okay, correct, very good. Okay, so if no problem with this, I don't want to waste a lot of time inside here. We carry on some more lah. Okay. Now, how if let's say got 3 functions? If got 3 functions, maybe you never see this type of question before, but it's the same concept, so same method lah. So here f g hx here is going to be x squared. Okay, now I take the x squared and substitute inside here. So x squared here will become x squared. So f1 plus x squared. Now take 1 plus x squared, the whole 1 plus x squared, and substitute inside the x over here. So here I'm going to get 2 bracket 1 plus x squared. So straight away you get 2 plus 2x squared already. Can you all understand this or not? So that's how basically you get the answer straight away lah. Okay, that's how basically you get the answer straight away over there. Okay, so HGF and GHF you can go and try by yourself later. No problem lah. Everybody can try. Okay, so besides that, nothing much over here. Okay, Let's look at example number 5 lah. Okay, we try and do example number 5. Okay, here they say f square x equals to x. So this is like basically map to itself lah. Map to itself back again. F square x equals to x. So f square x equals to x. Let's find f square x first lah. So f(x) will become 2 minus x. F here. Okay, don't forget the f in front, the 2 minus x there. Hold on. Just give me a second. Okay. Yep. Okay. So now I can put the f here. Okay. So here now you get 2 minus x. So basically you're going to get plus x over there. Yes or not? So show already lah. Okay. So shown already lah. So that's where you get x. Okay. Shown lah. No problem. Then the next one there, they tell me, they say, find the expression of g square x, state the two values of x that is undefined. So g square x. Now g square x is basically gx, which is g 3 over x plus 1, because the function of gx is 3 over x plus 1. Now 3 over x plus 1 plus with 1 here, because this whole x here I change to 3 over x plus 1. So I get 3 over 3 plus x plus 1 over x plus 1. So from here, this is very obvious. This will become 3 over x plus 1 over 4 plus x. Okay. So they ask you to find which two function the g will not be defined. So of course, over here, you know x cannot equals to negative 4. Okay. But the gx itself, you know one more thing here, that x cannot equals to negative 1. So you know that the function will not be defined for x equals to negative 1 and also x equals to negative 4. Why? Because gx itself is x cannot equals to negative 1. Then g square x cannot equals to negative 4, right or not? So both also cannot lah. Understand? Both also cannot. So here we take x equals to negative 1 and here we take for x equals to negative 4. So both of that will tell me that the function is undefined at negative 1 and negative 4. I hope that is clear lah for everybody. Any problem until there so far? Okay, because denominator cannot equals to 0. That's right. Correct. Rafiq. Okay, because denominator cannot equals to 0. That's right. Okay. Okay. Now, then they ask me to find h cube x there. So h cube x there is no problem lah. Just h x. Yes or not? Okay, 3 times 9 h x here. Okay. So h cube x here. So this is going to become h square x. Okay, or before that I find this thing like this first. Hx is 2x minus 1. Then h2 bracket 2x minus 1. Okay, minus 1. Hold on for a while. Sorry, the pen battery today is a little bit low. So yeah, this is the problem. Okay, when we use digital items, suddenly the battery will become low. Yes, not? Okay, so 2x minus 1. 2 bracket 2x minus 1 minus 1 here. So I get here h 4x minus 2 minus 1. So here you get h 4x minus 3. Now put back inside that thing again. 2 4x minus 3 minus 1. So 8x minus 6 minus 1, which is 8x minus 7 there. So I hope until there everybody clear lah how we are doing that. Okay. Okay, now we go to the next part here, example number 6. Now before I go to example number 6, let me define for you something lah. Okay, maybe I will teach you this way first before I move on. So I like to call this inside and outside method lah. Inside, okay, and there one more will be outside. Okay, so this is inside method first. Okay, hopefully I can see this. Okay, this is inside method, and then after that the other one more will be outside. So let's say if I give you fx equals to x plus 2, and I give you gx, fgx equals to 3x plus 1. Okay, you want to find gx. They say find gx. So gx is inside, yes or not? Gx is inside. So for me to find the inside method, okay, we write down like this. Fgx, write down the composite function at the top. Write down the single function at the bottom. Okay, so now you draw this arrow. You put gx inside, the x there. So this x becomes gx. Therefore, this also becomes gx. So now you get f gx equals to gx plus 2. And f gx is what? F gx is 3x plus 1. So here you take gx plus 2 equals to 3x plus 1. Okay, again I stress here is plus 2. Okay, this must equal back to the top one. So it's a round line. You all can see how the round going, right? Okay, so from here you make gx your subject. You get 3x plus 1 minus 2. So straight away you get 3x minus 1. Done. So this is called the inside method. Okay, this is called the inside method. I hope that is clear for everybody. Okay, maybe I can give one more. Okay, I give another one more here. Okay, fx equals to ln x plus 2. Okay, gx here. Okay, equals to 8x plus 1. Let's see lah. Okay, so you know one thing that f gx, you write down here first, 8x plus 1. Then you have fx over here, write down, equals to ln this time, x plus 2. Purposely I give this one a little bit more harder. So you can substitute the x inside here, so you get gx here, and you're going to get gx over here. And that equal back to at the top there, so you get ln gx plus 2 equals to 8x plus 1. Okay, so now you have to make gx the subject. How? This is base e, remember? So you bring up the e here. So you get gx plus 2 equals to e power of 8x plus 1. And then you bring over the 2 there. So you get gx equals to e 8x plus 1 minus 2. That's it. Clear? Can you all understand until here? So that's how basically you get the function over there. I hope this is clear for everybody. Okay, I hope this is clear for everybody. Any problem until here so far? So this is what we call inside method. Okay, got study before also in form 4. Not say never study. Okay, got study before in form 4 also. So since this is inside method, we have another one more. We call this outside method. Okay. Now, the outside method is basically involving how to find using inverse lah. Okay, by using inverse. But I haven't teach you all inverse function yet. The inverse function will be the next topic which we want to go and do today. Okay, so let me go to inverse first before, or I think, yeah, let me go to inverse first before I teach that lah. Okay, oh wait, let me just see. Never mind, I carry on, I teach first. Okay, so let's see the outside method right now. Now, the outside method, okay, the outside method over here, you all got study inverse little bit in form 4, yes or not? So you should be able to see this lah. Okay, the outside method will involve inverse. Let's say fx equals to x plus 1. Now this time gfx is 3x plus 1. Now look at the g. The g is actually outside. The g is outside, outside here. See, outside. That's why I use this outside method. Okay, so how do I find this? The first step is step 1. Find inverse of fx. To find the inverse of fx, so you use y equals to x plus 1. Y minus 1 equals to x lah. So you know that f inverse x is x minus 1. Okay, it's just x minus 1 there. Okay, after this I will explain a little bit more in inverse in the next part there lah. Okay, so now once you get this inverse ready, you just take g f inverse x equals to 3x minus 1 plus 1. Therefore, this will become gx equals to 3x minus 3 plus 1. Therefore, you get 3x minus 2. Done lah. Okay, now this is called the outside method. Okay, this is called the outside method. Now, don't worry so much about this. The reason is because I will stress this after this when I teach you inverse more lah. Okay, so let's see a few questions over here. If you look over here, you can see again, this is f gx x squared plus 6x plus 10. Then you have gx over here. okay, which is 3 plus x. Okay, 3 plus x. So they want to find f. Now, if you look over here, they teach another one more method. Basically, it's also the inverse method. It's the same thing. They are using the inverse method. This is outside. Okay, so here I know that I have to find the inverse of gx first. So let's find the inverse of gx. Y equals to 3 plus x. So x equals to y minus 3. So I can tell you f g inverse x, because g inverse x is x minus 3. Okay, this will give me x minus 3 square plus 6x minus 3 plus 10. So I get fx equals to x squared plus 1. Don't believe, you can go and expand lah. You will get x squared plus 1. Can you all understand that? Okay, they are using the same method, inverse method also. This is the process of finding inverse here. Okay, this is the process of finding inverse over there. So the method is still the same over there. I hope. Can. Any problem until there so far? Everybody okay until here so far? Can? Okay, I hope until here you are okay. Okay, if no problem, then I hope everybody understand now. I hope everybody understand. Okay, good then. Okay, let's move on some more. Okay, we move on a little bit more. Okay, we move on a little bit more. Okay, example number 8 there. Let's look at example number 8. Okay, if you look at example number 8, they gave you the function fx, they gave you the function gx, and then they gave you hgfx. Yes, okay, hgfx there. Okay, so they gave you x squared minus 8x plus 3 over there. Okay, so let's see over here how we can proceed with that. So of course, we want to find hx here. H is outside, am I right or not? H is outside. Okay, they want to find the function of h, but h is outside. And gf here is what we have to find first lah. So gf here, no problem. Gfx we can find. Gfx there is x minus 4. So I get x minus 4 squared. Okay, so I get x minus 4 square over there. Okay, so once I get x minus 4 square already, now from there, I want to find h over there. So the h there is going to take, I have to find the inverse of x minus 4 square first lah. So I let y equals to x minus 4 square. Y square root of y plus 4 equals to x. So gfx bracket inverse equals to x square root of x plus 4. So now to find the hx, okay, it's just square root of x plus 4, okay, minus 4 bracket square. Okay, you substitute inside the, wait, sorry, I substitute in the wrong place. Substitute inside this function here. Okay, substitute inside that function there. So you get square root of x plus 4 square minus 8 square root of x plus 4 plus 3 there. So here, very obvious, you're going to get here, you can expand out this thing. Okay, x plus 8 square root x, and then plus 16 minus 8 square root x plus 32 plus 3 there. So here you can get very obvious, x plus 19 plus 32 over there. 19 plus 32 there is 11 plus 40 minus 13, is it? Did I calculate wrongly? Oh, sorry, it's minus 32. My mistake. Minus 32, yeah, correct. So then it's minus 13 there. Can you all understand this not so far? Okay, minus 13 there. So you already get hx lah. Basically, you have to find the inverse of gfx there lah. Okay, you have to find the inverse of gfx. So there are some more questions over here for you to try and for you to see lah. Okay, which method to apply, inside or outside? Okay, inside or outside. So I'm very sure you all can try and see this part by yourself later. Okay, now we go on some more. The next function here is inverse function. Okay, the next part here is inverse function. Now, how can we see an inverse function? Now, remember one thing, inverse function, if in a graphical method, is actually a reflection. Okay, reflection on y equals to x. Okay, so inverse function, okay, I will write down here lah. Inverse function graph is obtained by reflecting on the line y equals to x. So any graph you have, you want to find the inverse, you just reflect on y equals to x lah. Okay, when you reflect on y equals to x, you already get the inverse function. So I hope that is clear for everybody. Any problem until here so far? Any problem until here so far, class? Can?
Yes, sir.
All okay?
Okay.
Can, huh? Okay, very good. So again, I stress, the inverse function graph is obtained by reflecting on y equals to x. Then. Okay, and the function of an inverse is symmetrical about y equals to x lah. Basically, it's symmetrical lah. Okay. So if you see, for example, you might tell me, sir, you have a quadratic graph. So a quadratic function is like this, right or not? Okay. So the inverse of a quadratic will be reflection on y equals to x here. So this point here will come here, and this point will remain here. Okay. This point will come here. So you can see that this graph is going to become something like this. So it's a set graph already. So a quadratic function will become a set graph. Now, why I only draw part of the quadratic function? Why I never draw this part? If I draw this part, then it's not a one-to-one function. If it's not a one-to-one function, then inverse does not exist. It must be a one-to-one function for inverse to exist. Remember that again. It must be a one-to-one function for inverse to exist. If it's not a one-to-one function, inverse will never exist. So like modulus graph have no inverse. Nah? Quadratic graph also, if you draw part of the graph only, then yes, it have inverse. Or if you draw the full graph, it doesn't have inverse. Nah? Because it's not a one-to-one function. Okay? Okay, and what do I mean by inverse function over here? So let's say that this is -3, is going this way. This is fx, right? Not? So it's -11. So from here to here will be the f inverse. Lah. So f inverse of -11 will become -3. Lah. Understand? That will be the inverse over there. And I think that one also you all studied before already. Lah. Okay. Okay. Let's see here. Now to see this thing here also, the inverse here I already summarized for you all also already. Okay, the inverse function f exists only if it's one-to-one function. Now the problem with inverse is right now we are going to use this formula. They will stress a lot on this formula. That's why the outside one just now, if you remember, they gave me GF, I put F inverse inside. When I put F inverse, this whole thing became X. That's why this thing becomes GX straight. That's why the outside method just now, if you really look, okay, outside here, what I can write down here, see, I wrote down here F inverse, okay, and I take the F inverse, which is X minus 1, substitute inside the function over here, means I put X minus 1 inside here. So that's why the whole thing there become GX, because F inverse X became X. When I substitute F inverse X became X already. That's why this is correct. Understand? Okay. So that's why we use these two formulas over here. F inverse X equals to X, or F inverse Fx also equals to X. Okay, both also is correct. Understand? Both also is correct. Now I want to stress another one more thing is that we will use this formula to find inverse. We will use this formula to find inverse. Okay. Let's see over here first. By graphical method to determine is it a one-to-one function and does it have inverse or not. So if you look at this graph over here, this graph is a horizontal line test, cuts at 2 points. Okay, therefore this is not a one-to-one lah. Okay, not a one-to-one. Why? Because it cuts at 2 points. Okay, it cuts at 2 points. So this is not a one-to-one, therefore no inverse. But if you want this graph to have inverse, can, not say cannot. You cut your axis of symmetry here. So you just draw this part here, or you just draw this dotted part here. Then yes, it have inverse lah. Understand? So if I draw only the dotted part over here, okay, if I draw only the dotted part, means x is less than 1 over here, less or equals to 1. Okay, then yes, this cuts at one point, but why not? This cuts at one point, then yes, it have inverse. So for a quadratic function to have inverse, they have to tell you, is it less or equals to 1 or more or equals to 1? Means less or equals to the minimum point of the x value lah, or the axis of symmetry. Understand? So lesser than the axis of symmetry, it have inverse. More than the axis of symmetry also, it have inverse. Okay? So that's what they mean over there. So I hope until there, everybody okay? Any question until here so far? Any problem until here so far, Ken? Can class? Okay, class, can? Okay, a little bit more, that's all. Okay, now look at this cubic graph. Yes, cubic graph have an inverse lah, no problem. This cubic graph have an inverse because this line here, so it cuts at one point, it have inverse. Okay, this line here also, this one also cut at one point, therefore it have inverse lah. Okay, but if I draw this curve here like this, then this is not a function itself. Okay, this is not a function, so this one have no inverse at all lah. If it's not a function, doesn't, the question of one to one doesn't arise anymore lah. Okay, reciprocal graph also have inverse because it's a one to one function. Okay, but if you look at a modulus graph, this one does not have inverse lah. Why? Because it cuts at 2 points. So since it cuts at 2 points, this is not a one to one function, therefore it have no inverse. Okay. Okay. Now the second part here is algebraic method. How to determine algebraic method? Okay, for one to one function. Okay, if we know we have it's a one to one function, we will know it have inverse. So let's look over here how we determine that. So for example, A there, I take 2x plus 3. Okay, now this is the sentence which you have to write always lah. Okay, for algebraic method, you have to write like this first. Okay, let I use A and B lah. They use x1, x2. Never mind, you can use A and B. Let A and B be element of real. And if FA equals to FB, therefore A equals to B. Therefore, it is 1 to 1. Understand? This is what the sentence you should write down first before you begin. Okay, before you begin. Then you write down FA equals to 2A plus 3. FB equals to 2B plus 3. So 2A plus 3 equals to 2B plus 3. Negative 3 and 3 will cancel off. Therefore, 2A equals to 2B, A equals to B. Therefore, it is a one-to-one function. Now I'm using algebraic method to solve the, I want to prove that it's a one-to-one function. Okay, it is a one-to-one function. I'm using clearly algebraic method to solve this problem here. Okay, let's see B line. Okay, let's see B. Okay, B is x squared plus 2x minus 5. So fx equals to x squared plus 2x minus 5. So first, your definition will be, okay, let A and B be element of real. So if FA equals to FB, therefore in N and A equals to B, therefore it is one-to-one function. Okay. But if let's say FA is not equals, I mean A is not equals to B, then it's not lah. Okay. So this conclusion will come later on. Okay. Let A be element of real, then FA equals to FB. So we can write down A square plus, or I can write down FA first. A square plus 2A minus 5. FB here will be B square plus 2B minus 5. So I get here A square plus 2A minus 5 equals to B square plus 2B minus 5. Minus 5 minus 5 can cancel. So now if I shift here, I get A square plus 2A minus B square minus 2B equals to 0. This is a quadratic equation, so I have to solve like this. Okay. Now from here, this is where the problem comes in. So here A square minus B square plus 2A minus 2B equals to 0. Okay. I think we can factorize this very clearly. Let's see how can I factorize this. A minus B, A plus B plus 2A minus B equals to 0. Okay, so I can take out a minus b here, and I get a plus b plus 2 equals to 0. So from here, I can tell you that this is a minus b equals to 0, a equals to b, the first one, and then a plus b plus 2 equals to 0. So a equals to negative 2, negative b. Therefore, it's contradicting already, right? Not. Therefore, it's contradicting already. So, since it's contradicting, okay, hold on. Since, okay, a equals to b and a equals to negative 2 minus b, okay, so a is not equals to b uniquely, okay, uniquely, therefore it is not one-to-one function, okay, therefore it's not one-to-one function. Okay, so if it's not one-to-one function algebraically, a equals to b must be only the answer lah, must only be the answer, then only it can be one-to-one. If not, it cannot be one-to-one. Clear until there, everybody? Any problem until there so far? Can understand that?
So I
Yeah,
don't
say.
understand how you got the A plus B plus 2.
This one is it? This part here is it?
Yes.
Okay, a minus b I factorize out, right? This one I factorize out here, yes or not? Okay, so here balance I get a plus b plus 2, right or not? Can you see that?
Oh, okay, thank you, sir.
Okay, factorizing, basically I just factorize out only. Okay, here of course lah, this one you can put in bracket lah, no problem. Okay, but at the end of the day, when you open up the bracket, it's the same thing there. Okay, that's what basically is going on there. Okay, so hopefully until there everybody okay. Any problem until there some more? It is many to one lah. Okay, Rafiq, it is many to one. Okay, but inverse function only exists if it's one to one only. Clear? This is many to one already lah. This is actually many to one. Wait, is it one many to one or one to many? I think this is one to many. Yeah, sorry, one going to many. Yeah, two different values of y. Understand? So it's one to many. Yeah. Okay. Sorry. Yeah, it's one to many there, Rafiq. Okay. Clear? Okay. Any problem some more? Okay. Any problem some more? But inverse only exists if it's one to one. Inverse only exists if it's one to one. Let's look at C line here. Okay. I'm skipping all the wordings there. So I get 2 over a plus 3 FB. The wordings is the same all the time line. Okay. So you get 2 over a plus 3 equals to 2 over b plus 3. Cross multiply. 2a plus 6 equals to 2b plus 6. 6 and 6 can cancel. 2a equals to 2b. So a equals to b. Therefore, 1 to 1. You can see. So C is a 1 to 1 function. Now they are using x1, x2, and I don't like to use x1, x2 because you get confused later, especially when it comes to this part here. You can see they factorize, right? Later you'll get confused here. Clear? So to avoid the confusion over there, okay, to avoid the confusion, you can use a and b. Okay, you can use a and b. Let's look at square root function over here. Square root function also a plus 4 equals to b plus 4, square root, square root. So if you square both sides, you get a plus 4 equals to b plus 4. Cancel, cancel. So a equals to b over here. Okay. But under modulus function is not. Why? Look over here. A minus 3 modulus equals to b minus 3 modulus. To get rid of the modulus, okay, to get rid of the modulus, we will write down like this. A minus 3, okay, equals to b minus 3, and then the other one more will be a minus 3 equals to negative b plus 3. So here maybe cancel, cancel. Yes, you get a equals to b, but over here when you will not be able to cancel, you will get a equals to, okay, here you get a equals to minus b plus 6. So it's contradicting line. Okay, contradict. Okay, so fa equals to fb does not apply. Okay, does not apply a equals to b. Understand? So you can write down that sentence over there. Okay, this is the best sentence to write down when you see lah. Okay, even in my lecture notes, lecture slides also, I already write down already what is the best sentence to write down. So if can, memorize the sentence lah. Okay, if can, memorize the sentence. If it's one to one, you write down like this lah. Okay, if it's not one to one, you write down all this already. Then you write down since A equals to B and A equals to negative 2 minus B. So FA, okay, you can maybe write down this. Oops, hold on for a while. It's voila. Okay, you can write down since A equals to B and A equals to negative 2 minus B there. So you can write down there that FA equals to FB does not apply. Okay, so you can write down here FA equals to FB does not apply, does not imply lah. Okay, imply that A equals to B. Therefore, it is not one to one. Not one to one there. Okay, so you all can write down that in words lah. Okay, so I stop until here first. Okay, I'm not going to go into the inverse part. Okay, the inverse part actually is not that hard. It's quite easy. Okay, maybe can I go into bit? I just go in a little bit lah, a little bit only. Okay, very fast. Okay, example number 3 there, how to find inverse. Okay, now to find inverse, we have to use the formula of f inverse x equals to x now. Now, your method of finding inverse using your form 5 method will not be accepted in matrix lah. Okay, it will not be accepted in matrix. But if you really cannot use the matrix method anymore, then you go ahead, just use any. Because so far I see exam papers, they give marks lah. Okay, they give marks still, even you use the form 5 method. Okay, so you write down this f inverse x equals to x. I'm teaching you the matrix method. So since fx is x minus 3, so you get f inverse x minus 3 over 2 equals to x, and then make f inverse your subject. So 2x plus 3, done. That's it. Okay, I do B there. Okay, if you look at B, they give me f inverse x equals to x. So I get 3 f inverse x minus 1 over f inverse x plus 5 equals to x. So I get 3 f inverse x minus 1 equals to x f inverse x plus 5x. You can shift, you get 3f inverse x minus x f inverse x equals to 5x plus 1. You can factorize out the f inverse x. You get 5x plus 1 over 3 minus x. I hope here you all can see. I take out the f inverse x. Here I get 3 minus x. That's how I factorize out lah. Okay, that's how I factorize out. Then from there I get over. Now don't forget x cannot equals to 3. Or if you can write down like this also, negative 5x minus 1 over x minus 3, x cannot equals to 3. This thing must be written lah. Okay, this x cannot equals to 3 must be written because you already learned how to define the function. Okay, so I will go on some more on inverse next lesson. Okay, on Friday, we will go and see inverse and how to find the domain and range of inverse. Okay, how to find the domain and range of inverse also. And what is the relationship between domain and range of inverse and fx function. So for right now, I expect you all to make sure you all can do one-to-one function, can sketch the graph, can sketch the inverse graph by reflecting on y equals to x. Okay, you can sketch the inverse graph by reflecting on y equals to x, and then from there you can proceed lah. Okay, so I hope until there you all can start doing, okay, on the exercise of graph which I have given, and start doing your exercise in tutorial also a little bit. Any problem until there, class? Okay, if no problem, this Thursday, hopefully I can give you all a short quiz, okay, on matrices. So please prepare yourself. The quiz will be as normal time at night, okay, and it will be the whole Malaysia taking place. So Mr. C.K. Tan will ready the quiz. You all can actually take part in the quiz and compete among yourself and see where you stand throughout the whole Malaysia. Okay, okay then, with that, thank you class. See you all next Friday. I mean this Friday, sorry. See you all this Friday later. Any question? If no question, I stop here today and I see you all back this Friday. Okay, thank you.
Thank you, sir. Thank you,
Okay,
sir.
thank you.
Sir.
Okay, thank you.